6.5 is rotation of a point. So we are taking a shape or a point and rotating around the origin. So it's not a reflection, it's spinning it in a circle. And you'll get to see on Delta Math this little more interactive piece of it to where you see it spinning. So what we're going to have is 90 degrees, 180, and 270 degrees counterclockwise. So hopefully you know that a clock would go like this. Counterclockwise goes backwards. It's how the coordinates go, quadrants, sorry, 1, 2, 3, 4. That is counterclockwise. So on a 90 degree, when I take a point and I go to the left a quadrant, think about what happens here. So this point, let's pick this pokey point, this really pointy spot right here, and here. This was at 9, 2, I know it's hard to see. And then here it's at -2, 9. So look what happens. They swapped places and then it made the x, the new x, the opposite sign. So think about here, every time it goes 90 degrees, it's going to actually swap places. And then think about x in quadrant 1 is positive, x in quadrant 2 is negative. So no matter where a point's at in a quadrant, I can always picture going from quadrant 1 to quadrant 2, it's going to change the x value. All right, 180 degrees counterclockwise would take something in a quadrant and go 2 quadrants to the left or counterclockwise. Let's pick, again, the one that stands out to me is this really pointy one. That point is at -9, 2. And the new one is at 9, -2. And so they have been not swapped, but just negated. The cool thing is this is actually the same as a reflection over the origin. What was the last one? Yeah, that's what we had, where I told you I don't always use a rule, but the rule on reflecting over the origin was just negating them. Okay, and so again, saying 90 degrees switches the x and y, then going another 90 would switch them back. So that's how I can kind of think. We don't switch, we just negate them. And then a 270 would be a 90, so something's going to switch. Let's pick, I'm going to pick this point and this corresponding point. This point's at -8, -2. And now the new one's at -2, 8. See how they're swapped, the 2 and the 8. And this time the -8 became +8. So I changed the y. Picture something again going from quadrant 1, let's say 1, and then counterclockwise 270 would be 1, 2, 3 quadrants around. So it went from up here where y's are positive to down here where y's are negative. So let's try those. And I'm just trying to get you to memorize these because you really just need to memorize them. Commit them to your brain. So what is the image of the point after rotation counterclockwise about the origin? So 90 degrees counterclockwise. I know every interval, so the 90 and the 270 is going to swap. I don't worry about signs. So I'm going to make it 6, 5. And then I know that the x value is going to be the opposite. So that was 6. Now that needs to be -6, but this should still stay -5. So I swapped them and I made this be the opposite. And so the -5 stays. All right, number 2. -7, -8, 180 degrees. I don't swap them because I've swapped them back, and I just make them the opposite sign of what they were. And then number 3, a 270. So I swap them back, swap them again. So now I'm going to swap my numbers, 4 and 2. I know that my y needs to be the opposite. And so this was a -2, now it'll become +2.